All right, let's now look at doing some definite integrals with u-substitution. So let's pick something fairly straightforward here. We're going to integrate from -1 to 1 of x times x squared plus 1 cubed dx. Right? So this integral here, of course, we could, expand this out, multiply it, and then integrate it as usual, but this will actually be better to do using u-substitution. So if we look at it, this piece here looks like a composition, and this piece right here looks like the inside of it. So we're going to pick u to be x squared plus 1, and then du is going to be 2x dx. All right, if we look at what's left over, we have the x and the dx here, which is this part here. So what we get here is this part becomes, the blue part becomes u cubed. The red part, we have to move this 2 over. And now, what do we do with the bounds? Remember, according to our rule, we just plug in these old bounds into this function here. So, u of 1 will be 1 plus 1, which is 2. And u of -1 will be also 1 plus 1, which is 2. So this turns into an integral from 2 to 2. So actually, this is a really poor choice of example, because we don't have to do any more work here. This just has to be 0, because we're integrating from 2 to 2. So let's go ahead and do another choice. But this is actually something interesting that can happen when we do the u-substitution here, is we do wind up sometimes with, our two bounds being the same. So let's try another example here where that won't happen. Let's integrate from 0 to 2 of x over square root of 1 plus 2x squared dx. Right? So here, the part of it that looks like a composition is the square root with the stuff on the inside. So what we're going to do is pick the stuff on the inside of this square root to be our u. Okay? And then we do our usual business, compute du. Du is going to be 4x dx. Here we have an x dx. Here we have an x dx. So we can rewrite our integral. And we're going to wind up with sort of 1 over square root of u, right? So, and then that takes care of the square root part. Now the x dx, we have our x dx here, so move the 4 over. We have 1/4 du, right? And again, to change these bounds to the new ones, we just need, well, what is u of 2? Plug that in, 1 plus 2 times 2 squared, which is 9. So the top bound turns into a 9. U of 0 is 1 plus 0, which is 1. So the bottom one turns into a 1. Right? So again, we just plug in the 0 here for x. That gives us the new lower bound. Plug in the 2 here for x. That gives us the new top bound. All right? So this is 1/4, 1 to 9, u to the -1/2 du. And so we use our power rule as usual. This is u to the 1/2. Let's do that. U to the 1/2 over 1/2 from 1 to 9. Okay. So let's see. This 1/2 here turns into a 2. So this is 1/2. Plug in the 9. And then plug in the 1. And so, computing this, we have 1/2 of 3 minus 1. And this actually turns out to be just 1 at the end of the day. Kind of interesting. Right? So that's kind of the idea behind doing u-substitution with definite integrals. So it's basically the same procedure, except when we change these numbers here, something really nice happens, which is that we actually don't have to change it back to x's. Now, of course, we can, if we wanted to, ignore the bounds, do the substitution rule to find an antiderivative, and then pop that back in here and plug in, 0 and 2. So it's completely up to you which method you want to do.